yearly basis. The location southeast of England, the system size, this is the system size, 4 kilowatt per hour. And then, because we are going off grade, I mean, at the moment, we're making the assumption that you're on the government grade, right? But if you go off the government grade, you are saving, what, about £350 per year because you are making use of your own power. So that's money you are saving, right, which you can set aside. And then the lifespan of this system is what, 35 years, right? This is all assumptions. You are assuming if you install it, it will take you 35 years before it gets spoiled. And at the end of that 35 years, you probably want to replace it. Whereas if you go in for the solar panel, right? The maintenance cost is what, every 5 years, we need to go through what, an antifreeze check, which costs us what, £100, right? And then we also do have what, pumps, which needs changing every 10 years at what, £150, right? So basically, when it comes to the maintenance cost for the solar panel, when it comes to the maintenance panel, for maintenance, there are two cost items here. What, the antifreeze being checked every 5 years, and then the pump, that is what's changing. So it means that for the antifreeze, every year will be what, 100 divided by what, 5? Right, which is 20. And then this will be what, 150 for every what, 10 years. So 150 divided by 10, 15. So our maintenance cost per year will be what, £35 per year, which is what we have here. Right. The lifespan of this system is what, 45 years. And then you have the cost of your system, being what, £3,500. That's the initial cost, how much you need to be able to install the system. And then here also, because you are going off the government grade, the assumption is you make a savings of what, £250. Right. So the question becomes, for these two systems, which one do you go in for? If you were to be purely on financial considerations, which one would you go in for? So what happens is that, the first thing you need to do is to be able to what? Describe the cash flow for the full life cycle of either system. Right. To describe the life cycle for the full life cycle, which means you need to be able to what, set up, columns in a spreadsheet, right? But then also, one other thing, something you need to know is that at the end of the life cycle, you want to be able to replace these two systems, right? Because once the life cycle ends, you don't want to get to a situation where maybe the solar panel had come to life cycle and you don't have money to be able to get a new solar panel. So we have what's called a sinking fund, which I'm sure you do know about. Anyone who has not heard of the sinking fund? You know. Okay. So sinking fund, sometimes what happens is that with sinking fund, you want to know, maybe you want to make, probably want to replace this camera in maybe 10 years time, right? But you know the cost of the camera now, it's let's say £1,000. You want to know, okay, at the end of every year, what regular amount of payment should I set aside to be able to get me the £1,000 equivalent in 10 years. So the sinking fund helps you know what regular payment you need to set aside every single year, right? So it could be that if you set aside £100 or maybe £50 every single year, by the end of the 10th year, you would have been able to accumulate what? Your £1,000, but also dependent on your interest rate or your investment rate. So to be able to calculate your sinking fund, you need to know the investment, the interest rate the banks are offering you. Or I mean, if you have to invest that money, what sort of interest are you likely to get on it? Right. So what we want to do here is because we want to be able to replace either of the system at the end of its life cycle, we want to know, okay, for every year, remember we are making savings at the end of every year, right? We're making savings because we run up the grade. So at the end of every year, we want to know how much we set aside, right, on a regular basis to be able to replace either of the two systems at the end of its life cycle, which is where we use the sinking fund I over 1 plus I raised to the power n minus 1. Let's ignore inflation. Let's assume inflation doesn't really, on a real life project, inflation will happen, right? But for now, let's just ignore inflation. But then we make use of a discount rate. So what we need to do, or what we do is that for every year, right, we need to compute the sum for every year, right? What's the savings we are making? What is our cost of maintenance for that year? How much we set aside for that year? And then once we get the net, we convert that net into the present value. So we compute a PV for each year of the system, and then we add to produce what's called a net present value for the total system. So this is what happens. We'll go through an example. So here, what happens is that what happened with assume a discount rate of 2.5%, right? And then one other thing, in going through the question, one other thing, we did mention that the domestic system loses about 1% of efficiency every year. So what we do here is that because we already know our variables, we need to set up So the first thing we do is to set up our key data, right? We know the initial cost of the system to be £7,000, right, for the water. We know we're making a savings of £350 per year. The lifespan of the system is 35 years, and the maintenance, we've already calculated the maintenance cost, right? So at year one for the photovoltaic cell, we know we're making a savings of £350, right? This is the savings we are making, £350. And then the cost, major cost here is the maintenance cost, right? Which is £20, right? And then we also want to be able to know, but then the saving is positive, right? So because it's a saving, we make it as positive. If it's a cost or an outgoing, we make it negative, right? So for year one, it's 20. And then sinking fund, we did say, you remember the formula for sinking fund?
Yes.
You do. This formula. So what happens is that at the end of the life cycle we want to know how much we need to set aside every year to be able to buy or build a new system. which means we need to calculate our sinking fund. It will be I. Our I here is what? A depreciation rate, which is what? As I here is the sinking fund rate, which is what we are assuming we'll get once we invest our money. Right. That's based on normally what banks offer you. So if you're investing the money at 6.5%, which is our I, divided by 1 plus 1 plus what? The I raised the power n. But n here is for the life cycle, the total life cycle, right? Which is what? 35. And then minus what? 1. This is just a rate. So this is just a rate, but we need to multiply this rate times the initial cost. Right. All it means is that for every year we need to set aside what? £56 for every year to be able to get over £7,000 because we are assuming by the life cycle we need another £7,000 to be able to buy a new system. So for every year, but then it's also an outgoing because we're setting it aside. Yeah.
It should be minus rather than positive because it's saving from. You have to put it aside.
Yeah, you put it aside. Yeah. So it's a cost for you. It's a cost for you. So it's negative.
Yeah. The numbers have changed now.
No,
it was not.
Sorry. It's a negative.
Yeah,
right.
It's a negative.
Right. So this is what it is. So for each of them, so at the end of the first year, right, the total outgoing, this is saving minus the 2 costs would be what? 273. And then you convert it to what? The present value. I mean, which is basically, yeah, you know the net present value, which is your future sum. So. So once we do that, we convert whatever money we have here into what its present value, right? Which is simply this money divided by 1 plus what? I raised the power. So all we do is what we convert it towards the present value. So you do the same for the second year. But remember, we said what for this one there's a degradation of what 1% per year, which means that for every year you lose your savings factor by what 1%, right? So for the second year, whatever you save for the first year times what times 99% of efficiency to be able to get that. You do the same for the subsequent years. The same for cost as well. I mean, your cost is constant, so it doesn't change. The second year, your cost of maintenance is still constant. And then your sinking fund, it's also constant, right up to what the life cycle of the project. So it's for about, that's also constant, right up to the life cycle of the project. So what you do is to sum all of them up, right, and what's converted into what the present value. So this is it for this is for the photovoltaic cell. We do the same thing for what the solar panel. I've only done for the first 5 years, right? Ideally, I should have done right up towards the end of the project life cycle, which is 35 years. But for this, I've just done it for the first 5 years. We also do the same thing for what this as well. We know our savings per year is what, £250, right? Our maintenance cost is what, £35, right? And then we also calculate sinking fund for that, which is, we go through the same formula, but then here the number of years is what, 45 years, right? So you take care of that adjustment as well. So which means for every year you need to set aside what, 14 pounds. And then your maintenance costs, I mean, that one is also constant. And then for this, unlike the previous one, there's no depreciation. I mean, your savings is constant because we do not have what, a 1% depreciation. So here, our savings is, the savings per year is constant. You realize there's a difference between this savings and that savings?
Yes, because it's fixed.
Yeah, because it's fixed. And then once you do that as well, you do some, so for every year, right, this is how much it costs you. But to be able to have a basis for comparison, you need to convert it to what? Into the present value.
But when you convert it to the present value, you are not going to sell it back again. Right?
No, you want to know the cumulative, I mean, you're doing cash flows for every year, right? But you want to know the cumulative effect. That if I'm comparing all these two systems over their life cycle, right, what will be their value in its present form? You're only able to compare two items when you have what a common basis. And the common basis is have been able to convert it into the present value.
What does the present value represent in this case? What does it represent? Because I can't get it.
Just comparing the value right now.
No. So what we're doing here, you need to once you do the computation,
Yeah.
right, for all the years. So this was for 35 years, this was for 45 years. Once you do the computation and convert it to what the present value, you then sum everything up. You then sum everything up, right, to help you know which of these two systems ultimately comes out cheaper. Without bringing it into the present value, you'll not be able to do that. So by converting it to the present value, then you sum everything up to help you know which of the options. So typically, like we just did, we set up the spreadsheet, right? And then we compare the system based on NPV. So what we've done here is that we've set the depreciation rate, we said was 2.5%, and the sinking fund of 6.5%. But typically on a project, you always need to work those out. And then we set what the sinking fund rate, which is how much we need to set aside what each year, right? And then we set up the spreadsheet so that each of these can be treated as variables, right? So what we did here, it's after, once we calculate the NPV for all the years, right? The last thing you do is that you compare the system based on NPV of the annual total cost income, right? Minus the initial cost of the system.
What is the NPV again?
The net present value.
Oh, sorry.
The net present value. So you need to sum all the net present value, which will tell you.
Then you compare to the initial cost.
Yeah, the initial cost to be able to come to a decision. So I mean, with the one we just did, you can continue this. We just did for the first 5 years, but you need to continue right up to the life cycle of the system and then help you calculate. I think we can take a 10-minute break.
Yes.
Sorry.